And welcome to the solutions for the number section of the predicted paper for paper 2 and paper 3 for the June exams 2024. Now this is going to be quite a long video, so feel free to stop it and come back to it later on if you need to, but I'm just going to get started. Remember, it's a calculator paper, so you'll see me pulling the calculator up as and when I need it. We don't want to do anything without a calculator that the calculator could help us with now. Okay, so let's get started on these video solutions then. So first thing we're going to look at is this question here. So Sean works at a company. His normal rate of pay is £12 per hour. When he works more than 8 hours a day, he's paid overtime for each hour he works. We want to find out how much he gets paid overall with his overtime and everything taken into account. So first of all, we know that he works for 10 hours and he knows that any more than 8 hours is overtime. So he works 8 hours normal time, 8 hours normal, which is going to be 8 times by 12, which, remember, use the calculator. We may be able to do this in our head, but just tapping the buttons on the calculator to guarantee the marks is fine. And then he works 2 hours overtime. Now the overtime rate, of course, is 1 1/4 times his normal rate of pay. So overtime rate, let's just work it out over here, is 1 1/4 times by his normal rate, which is £12. So 1 1/4, so we press shift and then the fraction button to make it to the mixed number button. And we type in 1 and then we type in 1/4, 1 1/4, and that's times by 12, and we can see that's 15. So his overtime rate is £15 per hour. So now we know he gets 2 hours of overtime, so that's 2 times by 15, which is 30, and therefore the two added together, 96 plus 30, and again you might think that's an easy calculation, but let's the calculator do it for us, and then that's £126 is how much that Sean earns for that day. Question 2. Diagram shows a prism placed on a horizontal floor surface. So this is a compare measures question, and we can see we've got the formula given there for the pressure, so we don't need to worry about remembering this formula here. It shows a prism placed on a horizontal floor. The prism has a height of 3 meters. The volume of the prism is 18 meters cubed. We need to find out what the force exerted by the prism is. So first of all, we need to know that we've got pressure equals force divided by area, or as some people remember it like this as well. And we need to find out the pressure. So let's imagine we cover up pressure. So it's force divided by area. All right, so the first part is going to be given by, sorry, I've done that the wrong way around. I know what pressure is, sorry. I was trying to make it so that the one that I know is first. So we need to put the pressure, which we know. So we know that the pressure is 75 equals force divided by the area, which we don't know. So we need to find out what the area is. So we need to find out what the area is, and we can find the area out because we know that the volume of a prism, which didn't come up on paper 1, so it's almost certain to come up on one of these remaining 2 papers, is given by area of the cross section multiplied by the height or the length, we'll say h. So we know the volume of the prism is 18. That was given in the question. Equals, we don't know the area of the cross section, so let's just call it A for area, but we know the height is 3, so 3 times A. So 3 times the cross section gives me 18. So now I can just do a little bit of solving. So I can divide both sides by 3, and therefore I get A equals 6 meters. So the area of the cross section, 6 meters squared, sorry, the area of the cross section is 6 meters squared. So now I'm in a position where I can use this formula. So this is what I meant to do before. Pressure, force, area. I want to find out the force, so it's the force that I delete. And it's pressure times area. So pressure is 75 multiplied by the area, which is 6. 75 multiplied by 6, let's let the calculator take care of that, times by 6, and that gets me 450 newtons, and that's my final answer. Question 3. Ruth left her home at 10 a.m. and walked to the library. She got to the library at 10:30 a.m. She walked at a speed of 4 miles per hour. Work out the distance that Ruth travelled. So first thing we need to remember is how long she's travelled for. So she's gone from 9 a.m. to 10:30 a.m. So that should be 1 hour and 30 minutes. However, because our formula is going to involve miles per hour, the time needs to be in hours only. It can't be in hours and minutes. So in hours, this would be 1.5 hours. It's 1.5 hours. So I need to use that in the formula. So speed, distance, time. We need to find out the distance, so let's delete that. And distance is therefore going to be speed times by time. So my speed is 4 miles per hour. My time in hours is 1.5, and we do 4 times 1.5 using our calculator, and we get 6. So my answer is going to be 6 miles. Next one. Ruth got to the library at 10:30 a.m. as you planned. She stayed at the library for 50 minutes. She then walked home. She took 1.25 hours to walk home. What time did she get home? So this section here, the calculator can help us, but I don't really feel that a calculator is necessary on a question like this. So we know we've got 10:30 a.m. That's her starting point. Let's see how long it took her to do all these things. So the library was 50 minutes. And then we had 1.25 hours to walk home. Now 1.25 hours is the same as 60 minutes for the hour. 60 minutes for the hour plus 15 minutes for the quarter of an hour. We just need to know these facts. I wasn't doing any working out there. We just need to memorise a quarter of an hour is 15 minutes. 15 minutes and 60 minutes add together. And then this part you might use the calculator for. 50 plus 60 plus 15. Plus 15. And we get 125 minutes. 125 minutes. That was in mins. Now we know that 60 minutes is an hour. So 120 minutes, 1 hour is 2 hours. So therefore, this is going to be 2 hours and 5 minutes. So now I'm in a position where I can add this on. And you don't do the calculator for this really, you just do it using your logic. So plus 2 hours, that's going to take me to 12:30 p.m. And then I need to add on my 5 minutes plus 5 mins, and that's going to take me to 12:35 p.m. 12:35 p.m. And just make sure we put the p.m. or the a.m. there. Question 4. Jamil makes a drink by mixing 1 part orange squash with 9 parts of water. He uses 750 millilitres of orange squash. He's going to put the drink he mixed into 1 litre bottles, work out the greatest number of bottles he can completely fill. So we've actually got ratio in this question here. The ratio is 1 to 9. That's the ratio that we're talking about there. So let's use my bar model because I always like to use this when I do these questions. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the left part was for orange and this was for water. So now I know from this here, he uses 750 millilitres of orange squash. So that was just 1 share. So that must be 750. All of these must be 750 as well. Now I could write them all in there, but you get the idea. They're all 750 all across there. He's going to put the drink he's mixed into 1 litre bottles, work out the greatest number of bottles he can fill. So for this, to find out the water, we're going to do 750, and we know it was 9 boxes, because we can count them, and we know where we got them from the question. So 750 times 9, and we get 6,750 milliliters. Now, of course, the drink also contains the orange. We must not forget the orange that we talked about here. So we must also add that on. So we do 6750 plus 750. We add all this together. So I'm going to get that what I've got already and add 750 onto it. And we get 7,500 milliliters. Now, we know that in litres we divide by 1,000. So let's remind the person that's marking it that we know that. Divide by 1,000 gets me 7.5 litres. So it says, what's the greatest number of 1 litre bottles Jamil can fill? And it's going to be 7 bottles. You can fill 7 bottles because the 0.5 is not going to fill another one, unfortunately. On to question 5a. Write 260 as a product of prime factors. So I'm going to do this using the factor tree method to start with. So I need two numbers that multiply to give 260. So I'm going to do 26 and 10. 26 can then be broken into 2 and 13. And we circle the primes. And then 10 can be broken down into 2 and 5, which I can then circle as well. So now I must remember in my final answer to write this as a product. So 2 times 2 times 5 times 13, which I think is even better written as 2 squared times 5 times 13. And that would be my final answer. And now we've got the section where we have to find and use this now. So I'm zooming out so we can see this. So we need the highest common factor of this. Now, if we notice carefully, the 260 is what we just found out here. So we're definitely going to be using that there. Now, the first thing I need to do on this question is I need to do the factor tree or the prime factorisation of 150 as well. So 5 times by 10, not 5, 15 times by 10, sorry. And then 15 breaks down into 3 and 5. And 10 breaks down into 2 and 5. So therefore 150 can be written as 2 times 3 times 5 times 5. So I'm going to use the good old school Venn diagram method here, which I'm going to now put the numbers which are in common in the middle. So both of these lists here, so we're talking about this list and this list, they both have a 2 in the middle. They both have a 5 in the middle. And the remaining things are just unique to this. So this was going to be this was the 260 and this was the 150 in this circle. So the 260 has an extra 2 and a 13. The 150 has a 3 and an extra 5 there. So the HCF is the two numbers in the middle multiplied together, which is 2 times by 5, which is 10. Now, another way to do this, which is the easier way, I think, but it's not the way that most people will do it, but I think this is the best way to do this with a calculator. You write the two numbers as a fraction. So 260 over 150. So I'm talking about the two numbers from the question. Type that in your calculator and see what happens. So I use the fraction button, 260 over 150, and I get, if I press the S&D button, I get 26 over 15. And then all I need to do is I say, what did I do to get from here to here? I divided by 10, so therefore that's the HCF. That is my favourite way to do this kind of question. Question 6, standard form. Give your answer in standard form. This is a calculator question, just combined with a little bit of knowledge of standard form. So the first thing we must do is be confident in typing these kind of numbers into our calculators without any errors, using the power buttons and such. So we must make sure that when we get caught at the top there, so you can see at the moment my cursor is at the top, we must press the right arrow to move down, then close my bracket, divide, open bracket, 7.5 times by 10, and then the variable power button, minus 6, right, and then close bracket, and then equals, and I get 0.0 0.456. Now that's not in standard form. So this in standard form is going to be 4.56 times by 10 to the power of, and I would have gone back 2 decimal places, so 10 to the minus 2. So times 10 to the minus 2. Question number 7. A map has a scale of 1 centimetre to 14 kilometres. On the map, the distance between Manchester and London is 18.8. What's the real distance? So let's quickly use a ratio table. So I know the map and real life. So on the map, it's 1 centimetre. In real life, that 1 centimetre corresponds to 14 kilometres. So I know that I'm looking for 18.8 centimetres. So I know to go from the distance on the map to the distance in real life, the relationship was multiplied by 14. So I can use that same relationship here, look, multiplied by 14. So I do that 18.8 multiplied by 14, and I get 263.2 kilometres. So I just use the ratio tables and they'll always fall into place. Next one, accurate scale diagram of a telephone mast and a box. So if it's an accurate scale diagram, this means that this drawing is actually drawn to scale. Now, what we need to do on this kind of question is actually very tricky to do without a piece of paper or tracing paper to help me. So I'm going to try my best to explain how to do this and make an estimate roughly. So the first thing we need to do is we know that whatever the scale is on this diagram, that 1.5 metres is represented by this distance here. We know that for a fact. So what we can do is, what I typically do is, I get a scrap of paper, like a corner of the tracing paper, I rip it off, just so it's got like a bit of an edge, and I'll just make a mark from end to end of this distance from this distance, so that's the same distance as that there. And then I turn this tracing paper or this scrap of paper sideways, and I just see how many times that distance fits in. So you just move it, then move it to the top, and then move another one, and just see how many of these fit into the pole, and then I multiply that by 1.5. So if it fitted into this pole 10 times, I would do 10 times 1.5. So let's have at least a decent have a go at whether I can actually get a decent answer for this. Is there a cheat I can? There might be a method I can do using a straight line, perhaps. So I've got a straight line there. I don't know if I can select the straight line or not. I don't think I've got a tool on here that can move straight lines, you see. And I don't want to mess my presentation up through. Okay, so I think what I'll do is, we know that distance from there to there is, that's better. That distance from there to there is a straight line. So let's just imagine that I've measured it to there. That's once. Then from there to there is twice. There to there is 3 times. There to there is 4 times. There to there is 5 times. There to there is 6 times. And there to there is 7 times, something like that. So it looks like 7.5 times. So 7.5 times by 1.5. So 7.5 multiplied by 1.5. Whoops. 1.5. And I get 11.25 metres. 11.25 metres. Now, of course, you could have got a different answer to me there, just because of the fact that I was doing it really roughly. Yours should be more accurate. But everybody will have a slightly different answer, because it's how you rotate the paper and how you do the marks on there as well. But anything that's valid will get you a mark. Number 9, Alan and Bispa share some money in a sum of money. Alan gets 1/8 of the money. Bispa gets half of the money. Chan gets the rest of the money. Alan gets £2.50. Work out how much money Bispa gets. Now, I know for this part of the question, the first clue is to do with Alan's money. I know that Alan gets 1/8 of the money. So 1, 2, 3, 4, 5, 6, 7, 8. So this is what Alan gets. He's got one of these. Now we know that one of these is worth £2.50. £2.50. So that's the whole money. The whole money is 8 parts. Why did I know that? Because it tells us that Alan gets 1/8 of it. So that's why I knew there were 8 boxes there. So if 250 is 1/8 of it, therefore the whole amount of money is going to be 250 scaled up for all of these boxes. So 1, 2, 3, 4, 5, 6, 7, 8. So I do 8 times by £2.50, and that gets me £20. Times by 8 equals £20. So the sum of money, therefore, is £20. Now, this is very, very useful to me because I know that Alan got 250. I know that Bispa gets half of the money, so Bispa gets £10. So Bispa gets 10. And there's no need for Chan in that part of the question. However, the next part is going to use Chan. So find the ratio of the amount of money that Alan gets to the amount of money that Chan gets. Now we know that Alan, so let's see, what Alan gets 250, and we know that Bispa gets £10, so that's £12.50 in total. We know the total amount was £20, so if I do 20, take away £12.50, I will get £7.50. You can use your calculator for that, of course. And now I need to give the amount of money Alan gets to the amount of money Chan gets as a ratio. So at first, so Alan is 250 and Chan is 750. Now that's not my final answer because it said that they are whole numbers. Now there's a way a calculator can help us on this. If we write that as a fraction, so if we write 2.50 over 7.50, the calculator should hopefully deal with this. So 1/3. So therefore 1 to 3. So what I did there was, I know the £2.50 on the left and the 150 on the right were the top and the bottom of the fractions. So when I press equals and fraction button, I know the 1 refers to the left number and the 3 refers to the right number. So 1 to 3. Question 10. In the Northern Hemisphere, the ratio of the area of land to water is 2 to 3. What percentage of the area of the Northern Hemisphere is land? So we know that Northern Hemisphere being land to water. So this is land and this is water. So we know that 2 parts are land out of 5 parts in total. Now we want this as a percentage. So we just do the fraction times by 100 with a calculator. So 2 divided by 5 times by 100, and we get 40%. So 40% of the Northern Hemisphere is land. Next one, 20% of the area of the Southern Hemisphere is land. Work out the ratio of the area of land to the area of water in the Southern Hemisphere. So area of land to the area of water. So land to water. We know 20% is land, so 20%, and therefore water must be 80%. So it's got to be 20 to 80. But we could have anything in between. You could have had 2 to 8, and then you could have had 1 to 4 as well. That would be absolutely fine. I'm just going to write 20 to 80. It did not say in its simplest form, so that would be fine for today. Question 11, compound interest. Now this definitely didn't come up on paper 1, so we're going to get used to that formula sheet for this one. So we get P 1 plus R over 100, all raised to the power of n. That's the formula we're going to use for both of these 2 accounts. So first one we're going to do is Ali, and then we're going to do Ben. So let's see, so for Ali, he invests £2,000, so that's his principal amount. And it's got an interest rate of 2.5% per annum. So 1 plus 2.5 over 100, all raised to the power of, and it says 3 years for all of them to the power of 3. And now let's do the working out for Ben whilst we're at the subject. So 1,600, open brackets, 1 plus 3.5 over 100, all raised to the power of 3. So let's do Ali first. So 2,000, open bracket, 1 plus fraction button, 2.5 over 100, close brackets, all raised to the power of 3, and that gets us 2153.78. I'm rounding to 2 decimal places because it's money, so that's the amount of money that Ali gets after the 3 years is up. Now let's do the same for Ben. 1600, open brackets, 1 plus 3.5 over 100, close brackets, raised to the power of still 3 years, and that gets me 1773.94. So 94. You must who will get the most interest by the end of the 3 years. So that's how much that Ben has got. Now, we might think that we've answered the question now. It feels like we have. It feels like, oh yeah, Ali definitely gets more money. But we must be very careful to read the full question on things like this. First of all, it reminds us to show our full working, which is fine. We've done that. But the next part is, of course, is this about who will get the most interest. So the interest is the difference between the starting amount and the final amount. So we can see Ali, he's got 2,000 to start with, and now he's got 2,153. So his interest is going to be £153.78, because it's this amount here, take away this amount here. Now, Ben, he's got interest. This might be a bit trickier, so I'm going to do the calculator for this one. So 1773.94, take away 1,600. He gets £173.94. And now we can see it's not as clear cut as it was before. Ben definitely is the one with the most interest. So Ben gets most, something like that. Next one, in the third year, the rate of interest for the shares accounts is changed to 4% per annum. Does this affect who will get the most interest by the end of the 3 years? You must give a reason for your answer. So it says the shares account. So the shares account is going to be for Ben. Ben was the one that used the shares account, wasn't it? Yeah, Ben used the shares account. Does this affect who will get the most interest? Well, of course it's not. Ben already got the most, and now he's getting even more percentage. So no, Ben was already the most interest. So 4% will increase this. So he's only going to get more money. Question 12. A new phone costs £679. The value of the phone decreases at a rate of 4% per year. What would the value of the phone be at the end of the 3 years? So for this question, we're going to look at the formula that we used in the previous question, which we saw is given on the formula sheet. But the important thing for this one is that it is a percentage, a decrease, sorry. It's a decrease, or a decay as we sometimes call this. So all we must do is we must do exactly the same thing, but this formula here now, the thing that changes is this just changes to a negative sign. So we get P1 minus R over 100 raised to the power of n. This formula is not given, so we just need to memorize that if it's a decrease or a decay, we change that for a negative. Now I can just substitute my numbers in, and it becomes as easy as the question which we did previously. 4% over 100, all raised to the power of n. Not the power of n, we naturally know the power of n, don't we? It's the power of 3. So let's do that. So 679, open bracket, 1 take away, fraction button, 4 over 100, close bracket, all raised to the power of 3, and we get £600 and 74 pence. And that's it. Job done. Question 13. David has twice as many cousins as Becky. Becky has twice as many cousins as Nishat. Nishat has 6 cousins. How many cousins does David have? So I'm just going to write some labels for these. So David, Becky, and Nishat. So these are the 3 people. Now the one thing that I know to start with, I know that Nishat has 6 cousins. So that's fine. Now it says that Becky has twice as many cousins as Nishat. So that must mean that Becky's got 12 cousins, because twice as many as 6 is 12. David has twice as many cousins as Becky. So that means that David must have 24. And that's all we had to do. So we're just doing the doubling twice, but it's making sure that we do these in the right order. If we double the wrong one first, like if we'd have doubled Nishat to get David's, then we wouldn't have got the right answer for Becky, and we wouldn't have got the right answer for David either. Question 14. Parallel lines and triangles. We didn't see parallel lines on paper 1, so very good chance of coming up. ABC and EDC are straight lines, okay? EA is parallel to DB, which is what we can see by these parallel indicators there. Work out the length of A to E. So we know that we've got some measurements here, which I would strongly suggest that you write on the diagram in a question like this. So E to C, so that means all along here is 8.1 centimetres. This is this length from here to here. That's there. That's 8.1 centimetres. Now D to C, which is the smaller of these two, let's do that in a different colour. That's just this length from here to here. That length there is only 5.4 centimetres. And then D to B, which is this length here. D to B there is 2.6 centimetres. Work out the length of A to E. A to E. So what we do is when we cut a triangle with parallel lines, we create 2 similar triangles. It catches a lot of people out, this kind of question. So I've got 2 triangles here. I've got one triangle which is DBC, which is the little triangle, which I'm going to highlight now. That's this one. That's the little triangle. And we've also got the bigger of the 2 triangles, which is this one here. So the bigger one is AEC, which is the one that I'm going to show you now from my highlighting. This is the big one, look. That's that one there. Now, what I need to do is I need to put my measurements that I know on here. So 2.6 there, 5.4 here, and we know this is 8.1 here. Now, I want to find out, in this question, A to E. So I want to find out this here, that I'm calling it X for the moment. Now, I know that to get the scale factor from an enlargement, when I've got similar shapes, I must do the biggest length divided by the bigger length, divided by the smaller length, and there must be corresponding ones. So what I mean by this is the side that corresponds to this. This is the side that corresponds to this, and this is the side that corresponds to this. Now what I need to do is I need to identify that the corresponding sides in this question are 5.4 and 8.1. So 8.1 is my big side, 8.1 here, divided by 5.4, because that's the corresponding side here. And let's see what the calculator tells me about that. And hopefully it won't be too bad a number to deal with when we get the answer. 5.4. And we get 1.5, which is not too bad. So it means 1.5. So what this tells me now is if ever I want to go from the smaller to the bigger in this question, I must multiply by 1.5. And if I want to go from bigger to smaller, I would divide by 1.5. So now I've got this established. This will help me on part B as well. So that's why I'm doing it in such detail now. So now I know that the side that I want to make the comparison of is DB and AE. So DB is here and AE is the corresponding side. Now DB is on the smaller triangle, so I'm going from smaller to bigger. So I'm going in this direction here. I'm going from smaller to bigger there. So it's going to be 2.6 multiplied by that scale factor, which is 1.5, and that should get me 2.6 multiplied by 1.5, that gets me 3.9. So 3.9 centimetres. And then A to C. So A to C is the side which is on the smaller triangle again, is 6.15. So 6.15 centimetres, we're told that. Just told us in the question. We need to find out AB. So A to B is just this little bit here. So this is actually a bit of a tricky question. Catch a lot of people out this kind of question will. So if we can find out what B to C is, which is the length from here to here, I can then take away the 6.15, which is, so I can take away the 6.15 from that to find out what A to B must be. So what I need to do is I need to find out, I'm going from the bigger triangle to the smaller one. So I'm doing 6.15 and I'm doing a divide by 1.5. So 6.15 divided by 1.5 and we get 4.1 equals 4.1. So I know that's 4.1 now, 4.1 centimetres. I know the whole thing is 6.15 because that's A to C. So if I just do now 6.15, take away 4.1, and that gets me, let's have a look, 6.15, take away 4.1, that gets me 2.05 centimetres as my final answer. Question 15. Jamie takes a scorecard, takes a card from bag A, and then bag B, list all the possible outcomes. So a pretty straightforward topic, but we don't want to lose silly marks on this. So we can have E, J, we can have E, K. That's it. That's all the possibilities with E in front. Now we do F, J, and F, K, and then we could have G, J, and GK. Now we can't have EE or EF or EG because they're in the same bag and it's one from each. Question 16. Last year, Jo paid £245 for her car insurance. This year, she has to pay £883. Work out the percentage increase. So look at how little this question looks, and yet it's worth 3 marks, and this is a dead cert topic to come up. And this topic is percentage change. And many people don't identify this as percentage change. They just identify it as a percentage increase or decrease question. So percentage change is the change divided by the original multiplied by 100. So what we need to do here is we need to see what the change is. So let's see what she's got. Her change is 883, take away 245, because that's how much it's changed by. 883, take away 245, and that's 638. So now we do 638 divided by the original. So it said last year. So last year, the earliest time period is the original. So 245, then multiplied by 100. So let's do that then. So 638 divided by 245 multiplied by 100, and we get 260.4. So 260.4%. It didn't say what to round it to, so I'm doing it to 1 decimal place. Question 17. Natalie has got a restaurant and she's making potato cakes. The weight of a potato to weight of cheese to weight of onion is 9 to 2 to 1. She needs to make 6,000 grams of potato cakes. Cheese costs £2.25 for 175 grams. Work out the cost of cheese needed to make these. And it's a big 4-mark question. So ratio bar again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my first bit. That's potato. Then we've got 2 shares, 1, 2, and that's for cheese. And then we've got the last one is the onion, which is just one share, which is onion. So I know that she needs to make 6,000 grams. Let's have a look. So 6,000 grams, because the whole the whole recipe, remember, this equals a potato cake. So these are the ingredients of a potato cake. So 6,000 grams is how many potato cakes I need to do. So I do 6,000 divided by, and how many boxes there are, which is 9, 10, 11, 12. So I do 6,000 divided by 12, and I show that working out so people know where that's come from. Divide by 12, whoops, and that gets me 500. So 500 of onion, 500 plus 500 is going to be 1,000 for cheese. So therefore, the rest of the part must be 1,500, 6,000, take away 1,500, and that gets me 4,500. Or I could have just put all the numbers in the boxes if I'd have wanted. That would be fine. Now it says that cheese costs £2.25 for 175 grams. Work out the cost of cheese needed. So if you notice, I didn't really need to find out the potato amount or the onion amount. It's actually only the cheese that I'm interested in this question once I get to this point. So all I need to do is how many packs of cheese do I need? So I do 1,000, which is how much cheese I need, divided by the amount in each pack of cheese. And that will tell me how many packs of cheese I need. So 1,000 divided by 175, which gets me 5.71428571429. Doesn't matter if I write all those. So I'm going to need approximately equal to, I'm going to need 6 packs of cheese, because 5 packs would not be enough, because I need almost 6. If I need anything more than 5, I'm going to have to buy 6 packs. So now I'm going to do 6 packs, which cost £2.25 each. So 6 times by 2.25, and that gets me £13.50, and that's my final answer. So £13.50. Question 18. A path is made of white and grey tiles. Don't need a calculator for this. 1/4 of the tiles are white. Write down the ratio of white to grey tiles. So a bar model will help explain this. 1, 2, 3, like this. Now we can see that 1/4 of them are white. So these are the white ones, and the rest must be black. So the ratio of white to grey, we can clearly see, is 1 to 3. We can see 1 to 3, look. There are a total of 56 tiles. Work out the number of grey tiles. So now I'm going to come back to my diagram above and put some information on there now. I know there's 56 tiles, so I can now do 56 divided by 4 to find out how many tiles I need. So let's get my calculator. So 56 divided by 4 gets me 14. And then, so it's not white to black, it was white to grey, sorry. So that's 14 there. And each one of these boxes is going to be 14. So 14 lots of 3, which is 42. So there'll be 42 of the grey tiles. Question 19, a very tricky looking density question. Now we need to know the formula for density. So density, mass, and volume. That's the first thing I'm going to do in this question, is do that little triangle there. And now, once I've got this, I can then start to do the question, or start to at least look at the question, knowing that I've got the tools that I need for it. There's a lot going on here for 4 marks, so let's see. The density of apple juice is 1.05 grams per centimetre cubed. The density of the fruit syrup is 1.4 grams per centimetre cubed. And the density of carbonated water is 0.99 grams per centimetre cubed. 25 centimetre cubed of apple juice is mixed with 15 centimetre cubed of fruit juice and 280 centimetre cubed of carbonated water to make a drink with a volume of 320 centimetres cubed. Work out the density of the drink and give your answer to 2 decimal places. Now, it might look complicated, but this is actually a very common kind of question. So what you want to do is you need to find out the mass of each one of these amounts, because I know how much volume I've got. I know what the density was, so I can find the mass of the apple, the mass of the fruit, the mass of the carbonated water, and therefore if I add all those together, I can then find out what they all come to together, and then find out the final density of the whole thing, because I've got the density of the whole drink. So when I get to the end, I'll be able to do that whole mass divided by that whole volume, and I can find out the overall density. So I'm finding the mass of each of these. So mass of apple first. So the mass of the apple is going to be, we know that mass is density times volume, D times V, and straightforward, that's going to be density is 1.05 times by the volume is 25. We'll come back to this in a second. I'm just going to put all my my working out first. I'd rather my working out looks really nice, so people can check it rather than rushing the question. M equals D times V, which is going to be 1.4 times by 15. And then finally, mass of water, or carbonated water I should say, mass D times V, and that's going to be 0.99 multiplied by 280. And so the biggest ingredient is the water, if you look. So first one, 1.05 times by 25, 26.25, and we don't round anything here. So I know we got round to 2 decimal places, but if something here comes out as more than 2 decimal places, I would not round it. We only round in our final answer. So 1.4 times by 15, and that gets me 21. And then finally 0.99 multiplied by 280, and that gets me 277.2. So therefore the total mass of the drink now, so total mass is going to be 26.25 plus 21 plus 277.2. So 26.25 plus 21 plus 277.2, and we get 324.45 grams. So therefore the density now, this is the easy part of the question. So density is going to equal mass divided by volume, which is 324.45, divided by the volume, which was given all along as 320. So we do 324.45 divided by 320, and we get, it's to 2 decimal places, so it's 1.01. What a nice question. Question 20. Harley's house has a value of 160,000 to 2 significant figures. Find the least possible value of the house. So we've got 16, 1, 2, 3, 4. So 2 significant figures, so that's 1 and 6. So the next number on this number line would be 17, 1, 2, 3, 4, because we're only looking at the first 2 digits when we're talking about significant figures, remember? 1, 2, 3, 4. So the least possible value of the house would be this point here, which is 1, 5, and between those there is going to be 5, 0, 0, 0. And then this here between the greatest possible value is going to be 1, 6, 5, 0, 0, 0. All we're saying really is what's the number between 15,000 and 16,000? No, 150,000 and 160,000. So between 150 and 160 would be 155, and between 160 and 170 would be 165. Next, part B. The value of Rita's house increased by 5%. Her house then had a value of £10,000. What was the value before the increase? So it's percentage change, this one is. No, not percentage, reverse percentage, sorry. So I know that it increased, and increase means add. So this is 100% plus 5% is getting me 105%. So I know that 105% of the cost of her house is £210,000. So now I want to find out what 1% is. So I just do, using my calculator, I divide by 105. And I do the same here, divide by 105. So 210,000, 210, 1, 2, 3, divide by 105, and we get 2,000. So 2, 1, 2, 3. And if that's 1% the cost of the house, I want to find 100% because that's the original cost. So times 100, and that's going to be £200,000. So her house before that was £200,000. Question 21. Andy went on holiday to Canada. His flights cost a total of $1,500. Andy stayed for 14 nights. His hotel room cost $196 per night. Andy used Wi-Fi for 12 days. Wi-Fi cost $5 per day. The exchange rate was $1.9 to £1. Work out a total cost of flights, the hotel room and Wi-Fi, and give your answer in pounds. So that's the important thing. It told us the answer in pounds there. So this is okay. These ones that I've underlined are going to need to be changed. However, I'm lucky because I know that £1 is worth $1.90. I know that for a fact. That's given to me in the question. So I know to go from pounds to dollars, therefore, is times by 1.9. And to go from dollars to pounds is divide by 1.9. That's the loop diagram I'm going to use for the rest of this question. So the hotel room is $196 per night. So I'm going to do 196 divided by 1.9 to change that into pounds. So 196 divided by 1.9, and we get that there, which isn't actually a very nice number. So because of that there, because I know that's not going to be a nice number to start with there, and I'm going to have to round at the end, I might be tempted to just do everything in dollars and then change it to pounds at the end. So let's do the 196 multiplied by the 14 nights. So we find the cost in dollars. And that way we don't have the long decimals in our multiplication, if you understand why I've done that. If you'd have done it the other way, you would still get the right answer, but it's just going to make the numbers not as nice. So that's in dollars, remember. So now I need to do 2744 divided by 1.9 to change this into pounds. And then we get 1444.21, because 2 decimal places, because it's money. So that's how much the hotel room is going to cost for Andy. Now the Wi-Fi is 12 days, $5 per day. So 12 times by 5, which is $60, sorry. And now we do 60 divided by 1.9. So 60 divided by 1.9, and that gets me £31.58. So I've got that, and I've also got the £1,500. So the total cost then, so total. So the total cost is going to be 1444.21 plus £31.58 plus 1,500, because remember the flights are still the same in that part there. So what I need to do now is I need to do 1444.21 plus £31.58 plus 1,500, and that gets me in total £2,975.79. Now part B, if there were fewer dollars to pounds, what effect would this have on the total cost in pounds of Andy's holiday? So if it was fewer dollars per pound, that means that every single time I was dividing by the scale factor. So let's just illustrate with an example. If it was fewer dollars, so let's just imagine, for really simplification, if it was $1 to £1, then therefore we would be dividing by a smaller number each time. So that would mean that the cost in pounds would actually be more, because we'd be dividing by a smaller number. If you're dividing by a smaller number, your number is bigger. So if I did 2,744 divided by 1.9, and I did 2,744 divided by 1, you can see that the cost in pounds now, the one on the right, the one with the 1, would be a bigger number than the number on the left there. So it would make it more expensive. So it would make the pounds more expensive. More expensive. Okay, question 22. Nazima uses this graph to find out the amount of money she's paid for the number of hours she works. So we can use this to find out anything that's in the range of the graph, and we can also find information outside the range if we know what we're doing as well. So first part, how much money is she paid for each hour that she does? So all we need to see is, we know that for 1 hour she gets paid, it looks like about £15. So it looks like about £15 there. And then if we look for 2 hours, it looks like she gets paid £30. So that means that in 1 hour, it looks like she gets paid £15. And then the next one I'd expect is 45, yes. And then I'd expect 60. It looks like 15 to me. Last week, Nazima worked for 36 hours. How much was she paid? So you can see 36 definitely goes off the graph. But we know from part A that each hour is £15. So therefore, 1 hour was £15. So therefore, 36 hours is going to be 36 lots of this, isn't it? Times 36 times 36. So we can just use the calculator for this. 15 times by 36, and that gives me £540. Question 23. A really nice problem-solving question here for 4 marks. In Spain, Sam pays €27 for 18 litres of petrol. In Wales, Leo pays £40.80 for 8 gallons of petrol, and it's the same type. €1 is 85 pence. 4.5 litres is 1 gallon. Sam thinks that petrol is cheaper than Spain than in Wales. Is Sam correct? You must show how you get your answer. So to get a valid answer here, I need both countries to have the same thing. So both countries, I think I'm going to make into euros and litres. So then we'll find out the cost of we'll find the cost of fuel in euros per litre. So I'm going to do euros divided by litres, and that will tell me the cost in euros per litre. So euros per litre. That's what I'm aiming for. So Spain is easy, because Spain is already in that form. So Spain, I can do €27 divide by 18 litres, 27 divide by 18, and that tells me it's €1.5 per litre. That was easy enough. Makes the question seem really straightforward. However, the Wales, everything is different, look. The money is in pounds and the fuel is in gallons. So I know that to go from euros to pounds is going to be multiplied by 0.85, and to go from pounds to euros is divide by 0.85. So therefore, so this is Wales. So I need to do the cost that Leo pays, which is £40 and 80 pence. That was in pounds. I need to divide that by 0.85 to get it in euros. So 40.80 divided by 0.85, and that gets me £48. So £48 there. That's the cost of the fuel in Wales. Now it's 8 gallons. So 8 gallons, and we know that's 1.5 litres. So I know that 1 gallon is equal to 4.5 litres. So I'm looking for how many gallons is it? 8 gallons. So 8 gallons. And we can see clearly the relationship between gallons and litres. So we can just multiply that by 8 and multiply that by 8. So we've got 4.5 multiplied by 8, and that gets me 36 litres. So 36 litres. So that's how much fuel that Leo gets in Wales. So now I can just use my same formula, look. So cost in euros divided by amount in litres. So 48 divided by 36, and that's going to be 1.33 going on forever euros per litre. And we can see clearly that Wales is cheaper. Wales is cheaper. So Sam is wrong. We can't just say that Wales is cheaper. We need to comment about whether Sam is right or wrong. Question 24. A is a point with the coordinates 5, 9. B is the point with the coordinates D, 15. The gradient of line AB is 3. Work out the value of D for 3 marks. So we know we've got 2 points on a line here. Let's just draw them out. I don't know if this is going to be an accurate sketch at this stage, because it might be that the 1 point is behind the other one. We don't know. So D, the 15. Now I know that the gradient of the line is 3. So I know that you need to revise the equation of a line for this question, because from this point alone I can find the equation of this line. So I know the equation of a line is y equals mx plus c, and I know that the m always refers to the gradient. So the gradient of the line, it says, is 3. So I know y equals 3x plus c, but we don't know what c is at the moment, but it can be found in a short step. So for this coordinate here, point A, I know that when x is 5, y is 9. So 9 is y, 3 times by, and we know x is 5. Sorry, I always substitute by brackets, sorry. 3 times by 5 there, plus c. So I know that that gives me 15 plus c. So I've got this equation here now. I've got 9 equals 15 plus c. So to get c by itself, I take away 15 from both sides. And if I take away 15 from both sides, minus 6 equals c. So now my equation of my line, if you like, is going to be y equals 3x minus 6. That's the equation of my line. So all I need to do to find my final answer out now is for point B here. I know that when I put D into the equation, whatever D is, I know that y is 15. So y is 15. So 15 equals 3 times by D, because I don't know what D is, minus 6. Now, get rid of the 6 first from both sides. Then we get 21 equals 3D. We divide both sides by 3. And then we can find out that D is hopefully 7. There's a lot going on there. Question 25. ABC is a straight line. The length of AB is 5 times the length of BC. So AB to BC is 5 to 1. That makes sense. A to C is 90 centimetres. Work out the length of AB. So let's just do my ratio. 1, 2, 3, 4, 5, 6. And I know that it was 5 to 1, so it's there. This is the length of AB. This is the length of BC. We know the whole length of A to C was 90 centimetres. So I'm going to do 90 divided by 6. And let's see what that gets me on my calculator. That gets me 15. So 15 centimetres. 15 centimetres, 15, 15, 15, 15. So now we should be able to use this ratio now. So we know that 15 lots of 5, or we could add it to itself 5 times. 15 times 5 is 75 centimetres. Question 26. Find the highest common factor of 60 and 84. Let's use the smart way that I showed you earlier. 60 over 84 is equal to, put it in the calculator, so 60 over 84, that gets me 5 over 7, so 5 over 7. So I must say to myself, what did I do to go from there to there? So 84 divided by 7 was 12. I would have divided by 12. So therefore the HCF is equal to 12. If I would have done 60 divided by 5, I'd get the same as well. Lowest common multiple. So I'm going to write this out again. 60 over 84 equals 5 over 7. Now what we must do here is, remember, you multiply the diagonals together. So 60 times by 7. So 60 times by 7, that gets me 420. Excellent. Next one, part B. Write down the highest common factor of A and B. So I've got this here. So what I might be tempted to do is I might be tempted to find out what number A is and find out what number B is. So we do 2 to the power of 3 times by 3 times by 5. That gets me 120. And then I've got 2 squared times 3 times 5 squared, and that gets me 300. And we want to find the highest common factor. Now we just write 120 over 300, and let's see what that gives me. 120 over 300, and we get 2 over 5. 2 over 5. What did I do to get from here to here? 300 divided by 5 is divided by 60. So therefore the HCF is equal to 60. Now, of course, some people might have done Venn diagrams and whatever here. That's fine. Just try this method because it saves you a little bit of time. Standard form. So 4, and then we know the decimal point moves 5 places. So 5 places, 1, 2, 3, 4, 5. So 4 zeros on the end. 0.007 in standard form. 7 times by 10 to the power of minus 3. Because the decimal point must go 3 places back. Give your answer in standard form for this one. Now we're going to use a calculator, and then we'll see what the calculator says at the end of it. So 4.2 times by 10 to the 3. And then we're going to have plus 5.3 times by 10 squared. Just type it all in one go. And we get, for that, we get 4730. That's not in standard form, so we need to write that as 4.73 times 10 to the power of, and where did the decimal go? It went from 1 to 3, it went 3 places, so 3 places, I had to move it, yeah. And another one to do with using the calculator, fraction button, 2.645 times 10 to the power of 9. And then we've got 1.15 times 10 to the power of 3. And we get 2, 3, and then how many zeros? Is that 5 zeros? 1, 2, 3, 4, 5. And that's going to be 2.3 times 10 to the power of 6. 28. Very straightforward use of a calculator question. 300 over 2 times 5. Just testing whether you can use a calculator or not. Next one, we'd be not doing any other method other than using a calculator on these. I'm hoping you can check, you can see that this section of the exam paper is not designed for you to do these without a calculator. It is specifically designed to check, do you know where the bracket button is? Do you know where the power button is? Do you know where the fraction button is? Reciprocal of 20. There's 2 possible answers for this. I could write 1 over 20, or I could write, so 20 reciprocal I could write 0.05 or 0.05. Remember, reciprocal means 1, flip it upside down. So 20 is the same as 20 over 1. Let's have a look at this. What's the total money that he spends? So pens come in 6-pack, so 6 for 82. So pens, 6 for 82 pence. This is pens. I'm going to have space on this. And I want to get 30. So we can see that's times by 5. So that's times by 5. So 82 times 5 gets you 410 pence. We'll probably do it in money, in pounds in the final part. Pencils, they're going to be, move my calculator over here for a moment. The pencils are going to be, it's 15, and that was for 45 pence. So 30 is going to be times by 2, and then times by 2. It's going to be 90 pence. Rulers. So rulers, they are 10 for £1.25. So therefore 30 is going to be times by 3, then times by 3. That's going to be £3.75. Use the calculator ideally. And then the last one is pencil cases. They're just 37 times by, I didn't want to, that last one I didn't want to do it in pounds, did I? I'm just keeping them all in pennies at the moment, sorry. So 375. Yeah, and that should have been, let's get rid of that decimal, just so we're working consistently in pennies at the moment, so we don't get a confusion at the end. And then we're going to have now pencil cases, 37 times by 30. 37 times 30, 37 times 30. That gets me 1110. So let's add all these in pennies, and then we'll divide them by 100, just to avoid the confusion. So I'm going to do 410 plus 90 plus 375 plus 1110, and divide by 100, and we get, oops, press equal, get that, and then divide by 100, and we get £19.85. So £19.85. Whoops, that will be the final answer there. Question 30. Here are 4 digits, okay? Get rid of this calculator a moment. Here are 4 digits. Largest possible 3-digit number. So the biggest, you just go 974. You start with the largest possible numbers. So 9 becomes the 100, 7 becomes the 10, and 4 becomes the unit. Here are 4 different digits. Put these in order to give the smallest possible answer to the sum. You must reach each digit once. So you want the smallest numbers to be in the tens. Okay, so the 1 becomes a 10, the 2 becomes a 10, and then the 8 and the 6, it really doesn't matter which way around we do it, because 18 plus 26 is the same as 16 plus 28. We've already done this one. It's a duplicate question, so I won't repeat that one. 32. Here's the charge in a car park. So 0.024 euros per minute. Parked his car in the car park at 10:45. When he drove out the car park, he had to pay 840 euros. What time did he drive out? So let's use a ratio table. So we know 1 minute costs him 0.024 euros. We know that when he comes out the car park, it costs him 8.40 euros. So I know that to go from minutes to euros, to go from here to here, must have been multiplied by 0.024. So to go in the other direction, I must have divided by 0.024, because that's how these work. So now we're going to do that. So we're going to do 8.40 divided by 0.024, and that's going to be 350. 250 minutes. Now, I've still got quite a bit of work to do on this yet, because I need to see how many hours that is. So 350 minutes. Well, I know that 60 minutes is 1 hour, 120 is 2, 180 is 3, 240 is 4, 300 is 5, 360 is 6. So it's going to be 5 hours, that's 300 minutes, and 50 minutes. So now I need to make sure I add this on. So let's just go and make myself some space down the bottom here. So I'm doing 10:45. Let's add the 5 hours on first, which takes you to 15:45. That's the 5 hours done. Let's tick those off. Now let's get to the next easiest number, which is 4 o'clock, which is 1600. And I've used 15 minutes of that there. So if I use 15 minutes of that 50 take away 15 is 35. So I've got 35 minutes left. So 35 minutes left. So that's going to be 16:35. What a nice question that is. All the stuff that's going on in that question all in one. Question 33 about Jack's driving school. It's got 2 offers. Offer 1 is the first driving lesson is free and all the other lessons are normal price. Offer 2 is all driving lessons are 5% off the normal price. The price of a normal driving lesson is £24. Douglas is going to have 12 driving lessons. Which offer is cheaper? Okay. This is a nice, very, very simple kind of setup for this question. So offer 1 and then offer 2. And then we'll see which one is the best. So offer 1, his first driving lesson is free. So he's got 12. So he's going to pay for 11. So 11 times by 24. 11 times 24. And that gets me £264. That's how much he's going to pay. Now offer 2 is going to be 5% off the normal price. So that's going to be 12 times by 24. We'll find this answer out and then we'll take 5% off it. So 12 times by 24, and that gets me £288. But I want to find out what 5% off is. So 5%, 5 divided by 100 times by 288. 5 divided by 100 times by 288 gets me £14.40. So I need to take that away. So 288, take away £14.40. So 288, take away 14.4. That gives me £273.60. So we can clearly see that the first offer is better value. So offer 1 is best. Offer 1 is best or cheaper. Should say cheaper, yeah. Question 34. Dave goes into a cafe and buys 2 cups of coffee and a piece of cake. Each cup of coffee costs £2.75. Each cake costs £2.90. He pays with a £10 note. He thinks you'll get more than £1.50 change. Is he correct? You must show how you got your answer. So very straightforward the setup for this. So we're doing 2 times by £2.75 to find out the cost of the coffee. The cake is then £2.90, so let's do that first. 2 times £2.75, get £5.50. And then we've now got the cake costs £2.90. £2.90. So we're going to do total cost, which is £5.50, plus £2.90. So £2.50 plus... not £2.50, £5.50, sorry. Plus £2.90. That gets me £8.40. £8.40. And then I do £10, take away £8.40. So 10, take away 8.4 is £1.60. So £1.60. He thinks you'll get more than £1.50 change. Yes, he is correct. He is correct. 35. That's a duplicate question again. Apologies. So we'll just imagine that question 35 is the one about Bill's counters. He's got 400 counters in a bag. He gives 35 of the counters to Samina, 50 of the counters to Henry, 75 to Lucas. What fraction of the 400 counters that is left in Bill's bag? Give your fraction in its simplest form. So the fraction in its simplest form is going to be easy on a calculator. So we do 400, take away 35, take away 50, take away 75, find out what's left. They're trying to get you to trick you into doing this without a calculator. That's what they're doing on this question. They think, oh, we'll keep the numbers looking easy and hoping that you'll do it and make a mistake. So you've got 240 are left. What fraction are left in the bag? 240 out of 400. And that's going to be 24 out. No, let's not do that. We just use the calculator straight up. I don't want to do that because we want to use the calculator as much as possible. That's going to be 3/5. Just press equals. Just type it in the calculator and press equals. That's the easiest way to deal with it. One of these symbols to make it a true statement. 14 is less than 21. 4 plus 7 is 11. 103 take away 92 is equal to 11. So this is an equal sign. 2 squared is 4. 2 times 2 is 4. So they're equal. And 0.3 is greater than minus 3 is greater than minus 5. And the last one here is another duplicate question. So we've now finished. So thank you very much for watching. That's almost an hour and a half of video solutions for this here. If any of those questions are still outstanding in your understanding, please ask your teacher, reach out, let us know, and we'll be able to help you further. But if you're okay with all of this, move on to the algebra, data, and geometry videos. Thanks again for watching. I hope this has been helpful for you.